Let's work through some problems on this, more on related rates, assuming that you were okay with that first worksheet. And here is a classic situation. So we have a situation where, in fact, if we were going to draw a diagram, we're going to have a right triangle. So we have a 5-foot ladder leaning against a wall. So I'm going to draw this situation. So here's our ladder. And what I know is that's a constant. So that's 5 feet long. And it slips in such a way that its base is moving away from the wall. So right here's the wall, and here's the ground. And this is moving. So what I know is that this is changing. So I'm going to give this a variable. I'm going to call that b. And what we know is that dB, dt, the rate of change of b is 2 feet per second. And we know that that's going to be 2 feet per second when b is equal to 4. And what are we looking for? We're looking for how fast is the top of the ladder moving down the wall. So how fast is this changing? And again, since this is changing, this is going to be a variable. So I'm going to call this h. And we're looking for what dH dt is at that moment. So for a related rates problem, we're always looking for the relationship between these rates of change, the relationship between the rate of change of this and this. And we need to start with something. So what we're going to start with is our static relationship. We've got a right triangle here. So I know that h squared plus b squared is 25. And from this, I can take the derivative with regard to t of both sides. So that's going to give me 2h times dh dt plus 2b times db dt is equal to 0. I'm going to divide both sides by 2, so I'll just get rid of this. I happen to know, let's see, we know dB dt, so this is going to be 2 feet per second. And b is 4 feet. And let's see, dH dt is what we're looking for. And h at this moment, well, at the moment when b is 4 feet, I know that h has got to be 3 feet, right? We have a 3, 4, 5 triangle. Good. So now when I go to solve for dH dt, I'm going to have 3 feet times dH dt equals -8 feet squared per second. And I'm going to divide both sides by 3 feet. And you can leave the units off, but sometimes it's kind of good to put them on just to make sure that you get the unit that you anticipate. So dH dt, then, dH dt is going to be -8/3. One of these feet is going to cancel out, feet per second, and that makes sense in terms of this ladder slipping down the wall, right? That's going to be in feet per second.